Hi guys, it's Mrs. Hedrick. Hey, listen, so we're gonna try some video math lessons and we're gonna see how it goes. Right now, this is my Math 7 class. We are gonna be working on lesson 18. We're here in my basement. This is usually Mr. Hedrick's workout room. So I'm borrowing his dry erase board. We're gonna use it for a little while. To take care of our math lessons. So that's where I'm at. If you hear any strange things upstairs, it's dinner time. He's upstairs cooking, so we'll see how it goes. Okay, today for math, we're going to take some notes and we're going to work in our instruction book. So here's what you're going to need. You're going to need your math spiral if you brought that home. If you didn't bring it home, go get some notebook paper, fun colored pens, whatever. Grab a pencil, so when we write in our book, you have your pencil. I'm trying to think what else. You might need a calculator. Yeah, so we'll give it a go. Pause me at any time. If I'm going too fast, if I'm writing too quickly, if you don't understand something, rewind it, listen to it again, or hit pause if I'm going too quickly for you, okay? All right, so let's start with some notes. So grab your spiral notebook or notebook paper and some writing utensils. Okay, so we're in lesson 18. The title of the lesson is Problem Solving with Angles, so I'm going to write that up. Okay, problem solving with angles. Okay, so before we get started, let's do a quick review about some of the things we already know about. Let's start with some lines. Okay, parallel lines. So let's add those into our notes. Okay, what do we know about parallel lines? Well, okay, if you think of railroad tracks, so if I lay my notes down here, the sides of the tracks are parallel. That means that they never touch, they never intersect. Even if they keep going in both directions, they're never going to touch. So let's write that. I'm going to write never intersect. So parallel lines never intersect. And then we can draw a picture of that. Okay, so those are parallel lines. They never intersect. Okay, so what if we wanted to talk about perpendicular lines? I'm going to switch colors now. Perpendicular. Okay, what do we know about perpendicular lines? Okay, so no one's watching. Take your arms. So if these are parallel, show me perpendicular. What would they look like? So maybe I would do this, or I could do this. I could do this. Okay, those are perpendicular lines. But notice they cross, they meet at a certain angle. What angle is that? Yes, 90-degree angle, right angles. Okay, so in my notes for perpendicular lines, I'm going to write that they intersect at 90 degrees, or right angles. And remember, intersect, that means that they can cut all the way through or they can touch. So that's intersecting, even though it doesn't go all the way through. Okay. So they intersect at 90 degrees, or we could say right angles. Okay, and let's draw a picture of what that might look like. So I could draw, like, it looks like a plus sign or a cross. Sometimes in your math book, they'll put a little square there. That's to show you that they're perpendicular because the angles on a square are all 90 degrees. Sometimes it looks like an L. Sometimes it might look like a T. But again, those all intersect at 90 degrees. So those are perpendicular. The next one, let's just talk about intersecting lines. What are intersecting lines? I'm going to erase. You're just going to skip a line and keep going. Okay, so intersecting lines. hear the word in there, intersect, intersecting. If you think of like where two streets, an intersection of two roads. And that's really what this is. The only difference between intersecting and perpendicular at 90-degree angles, and intersecting can intersect at anything that's not 90 degrees. So my notes, I have that they cross but not at right angles. So I'm going to say lines that cross not at 90-degree angles. Okay, so we could draw some pictures of these. So, what do I have here? Maybe like, kind of like an X. Those are intersecting, but none of these are 90-degree angles. Or you might have one that kind of crosses like this. Also, intersect can also mean that they don't always cut clear through. So you might have a line that comes this way, maybe one that comes off here. Still intersecting, none of those are 90-degree angles. Okay, now let's move on to some of the ones that are a little bit harder. Okay, the next one I want to talk about are complementary angles. If you want to get in your math book, complementary angles, the definition for the next three words are on page 173. So if you want to open to 173. Okay, so I'm going to switch up colors here. Let's go, let's talk about some green. All right, let's talk about complementary angles first. So let's write our definition. Let's spell it correctly here. Complementary angles. Okay, that green's kind of light. Hopefully you can see that. If not, use your book or listen. I'm going to read it to you. Okay, complementary angles. These are two angles whose measures equal 90 degrees. Two angles whose measures equal 90 degrees. Now there is an exception to this, or an extra rule. They don't have to be adjacent. The two angles don't have to be adjacent. They do not have to be adjacent. Okay, what does adjacent mean? All right, so adjacent is kind of a fancy word for next door. These two angles don't have to necessarily be like next door neighbors. They don't have to be touching side to side. Sometimes they do, and most of the time they are adjacent. They're like next door neighbors, but sometimes they're not. So in your definition, I have two angles whose measures equal 90 degrees. They do not have to be adjacent. In parentheses, I'm going to put next to each other. And I know you're probably sitting at home thinking, why should I write these notes down? I can just go back and watch your video. You're going to want these notes because when you go to take your quiz, you are certainly welcome to use these. You can look at your book as well, but I think the act of writing them out and going along with me will certainly help reinforce some of this. Okay, so you got this, we can do it. All right, so let's draw some pictures. Okay, so the first one I have, I'm going to draw like a right angle. Let me switch to black in case you can't see this. Okay, so this would basically be my 90 degrees, and then I'm going to cut them. So one a little bigger than the other. Now, I'm not getting a protractor out. I'm not measuring these right now. So these are close, the measurements. We're going to pretend that those are the measures. So we're going to pretend that this one is 30 degrees, and this one is 60 degrees. Okay, now, inside, we're going to use this part. It's like part of a circle. It's called an arc, an ARC. I'm going to draw an arc in this angle and tell you that this angle is 60. And I'm going to draw an arc in here and tell you this angle is 30 degrees. Notice I have the little degree symbol. Make that little circle tiny and put it up like where an apostrophe would go, like an exponent. All right, now let's show that these equal 90 degrees. So I'm going to say 30 degrees plus 60 degrees equals 90 degrees. So these are complementary angles. Complementary. Okay. Those are complementary angles because the sum of the two angles is 90 degrees. Okay. Now, these are adjacent. They're next door neighbors. But what if they're not? Okay, well, let's do an example where they're not. All right, so I'm going to come to this side. All right, I'm going to draw my angle. I've got an acute angle. I'm going to draw my arc, and I'm going to label this 45 degrees. And I'm going to draw one that looks just like it. I'm going to have it point the other way. Draw my arc, 45 degrees. Now, if I add 45 and 45, I should get 90. So 45 degrees plus 45 degrees equals 90 degrees. These angles are also complementary. They are not adjacent. They don't touch each other. I could have even drawn them very far apart. I just kind of put them close to each other to fit them on the board. Complementary, complementary. Adjacent, not adjacent. They still work. Okay, now, the next one that we're going to do are supplementary angles. This definition is exactly the same. I'm going to change one thing. What am I going to change? You think about it while I'm erasing. Okay, I'm going to change it to supplementary. We'll go back to purple. Make sure I spell it correctly. All right, supplementary angles. Did you figure it out? What am I changing? One thing. You got it. What's underlined? I'm going to change it from 90 degrees. I'm going to double it. I'm going to make it 180. Everything else exactly the same. So two angles whose measure equals 180 degrees, they do not have to be adjacent. They don't have to be next door to each other. They can be, they don't have to be. Okay, now let's do our examples and I'll talk about how to remember the difference between the two of them. Okay, so I'm going to draw, here I'll do my examples in black. Okay, I'm going to draw a straight line. Right, please tell me you remember that a straight line, if I do this, how many degrees? 180, okay. But I'm going to take that out and I'm going to draw another line to intersect. I'm going to go, how about like this? Okay, put your arc. This is 45 degrees. What would this one be? Well, it would be 180 minus 45. 180 minus 45, 135. 135 degrees. Now, I can tell by looking at this that these are supplementary, but let's go ahead and show it. 135 degrees plus 45 degrees is 180 degrees supplementary angles. All right, now let's draw one more example over here. I'm going to draw a very large obtuse angle here. Draw my arc. This one is 150 degrees. And then over here, I'm going to put it below it so it's not next to it. Okay, smaller angle, acute. Draw my arc. Do you know what it is? 30 degrees. Now I can prove this one as well. 150 degrees plus 30 degrees equals 180 degrees. These are both supplementary angles. Okay. How do you tell the difference between supplementary and complementary? Okay, one, you can look at your notes. The way I remember it, if I go in alphabetical order, C comes before S. C is the lower number. It's lower in the alphabet. So C, complementary, 90 degrees. You keep going on the alphabet. S, farther along in the alphabet, 180 degrees. That's how I tell the difference. Okay, and then one more set. I'm going to pause you for a second. I'll be right back. Okay, sorry, I didn't need to pause. Okay, last one. Do you know what it is? Vertical angles. I like vertical angles. They're kind of cool. All right, so let's do our definition for vertical angles. Okay, vertical angles. Okay, the definition is in your book. I'm going to go ahead and read to you what I have, and we're going to write it. When two lines intersect, they create opposite angles or vertical angles. angles. They have the same measure. All right, so let's write that. When two lines intersect, they create opposite angles. Also known as vertical angles. This one has two names: vertical angles, opposite angles. Okay, now the important part about this is that they have the same measures. This is pretty good stuff. This is pretty helpful. They have the same measures. Okay, so let's draw a picture. All right, so I'm going to draw a big X. I have two lines that intersect. When two lines intersect. Okay, if you count this up, there are four angles here, right? 1, 2, 3, 4. There are two sets of vertical angles. Vertical angles are opposite. Here's another trick. Vertical angles have a V. So I'm going to pick a V. I'm going to switch colors. Let's say I pick this V, this angle. That's one of the angles. I want the one that's opposite. So which way would I go for opposite? I'm going to go across. So this angle is opposite. These two angles are vertical angles. They're opposite angles. They have the exact same measurement. So if I know the measure for one, I know the measure for the other. So let's pretend that these are, I don't know, what do you want to say? 50 degrees. So if this one's 50 degrees, the one that's opposite is also 50 degrees. Okay, now I'm going to blow your mind. You ready? What's this angle? Come on, you know it. These are supplementary angles. This angle plus this angle make a straight line. So what's 180 minus 50? 130. So this angle is 130 degrees. Notice it's a V. It's kind of stretched out. What's opposite of that angle? Aha. This one is also 130 degrees. Now, if I add all of these together, do you see what I've drawn in the middle? I have a circle. How many degrees in a circle? 360, you got it. This is 180, that's 180, 180 plus 180 is 360 degrees. So, kind of cool. I like these. These are a lot of fun. Okay, these are my notes for the lesson. What I'd like to do right now is, let's see, let's go over, page 174, 175. So go ahead and pause me here for a second, run to your book, 174, 175, I'm in the instruction book, grab your pencil. Okay, I'm going to clear my board. Okay, we're in the instruction book, page 174, 175. Okay, and this is usually where I ask for you guys to read the question in the yellow box, but you can read along with me. Okay, in the figure shown, what is the measure of angle ADC? So when I see this, I always take my finger, find A, slide it across to D, and then slide it down to C. So ADC. All right, first thing I notice is that it's obtuse, right? That's a large angle, so that's gonna be more than 90 degrees. The other thing I happen to notice, that's a vertical angle, that's opposite. I see that on the other side, right? Do you see that 2x plus 1 in parentheses degrees? Those should have the same measures. Okay, let's keep reading. All right, model it. You can use the diagram in Facts About Angles to write an equation. Angle CDE and angle EDF are supplementary angles. Supplementary, that means they equal 180 degrees. So in your book, you can see that they have written, well, I'll do it in the same colors. 2x plus 1 in parentheses plus, make sure I can read it, 2x plus 1, x minus 7. Okay, and then if they're supplementary, that means they're equal to, supplementary is 180. Okay, now solve it. You can solve the equation to find the value of x. So this is algebra. This is going back to those lessons we have already done. Okay, so what's the first thing that we're going to do? Look at, they went from this to 2x plus 1 plus x minus 7 equals 180. What did they do? How did they do? What did they do? Nothing tricky. They removed the parentheses. So we're going to write remove parentheses, okay? Now I have 3x minus 6. Now let's see. 3x minus 6 equals 180. Let me get that out of the way. Right? I should have drawn my line. Okay, you remember this. How did they go from here to here? Do you know what they did? I know what they did. You do too. They went through and combined like terms. Remember this? You know this. I'm going to go through, I'm going to circle all of my x's. I have a 2x, and I have a plus x. And then I'm going to box all of my numbers. Positive 1, negative 7. Okay, so let's see. What is 2x plus 1x? 3x. What's a positive 1 plus a negative 7? Negative 6. This side stays the same. So what did we do here? Combine like terms. Okay. Now it's just algebra. We know what to do here. How did they go from, how did they get 3x equals 186? Right? They added 6 to both sides. So plus 6, 3x equals 186. So we're going to add 6 to both sides. Okay, and then you know what to do here. I need x, so I'm going to divide by 3. So divided by 3, divided by 3, x equals 62. Okay, we're going to divide by 3, both sides. Okay, so not too bad, right? We've done this. It's refresh your memory, right? So take your time if you need to pause this and look at it a little closer. Okay, I'm going to erase and let's go over the questions on page 175. Okay, you can write these out or you can say them, however you'd like to do it. Let's read number 2. Look at model it. How do you know that angle CDE and angle EDF are supplementary? How do we know that? What could we write there? Pause, write your answer, say it out loud right now. You don't have to write them down. That's okay. You can if you want. Did you say that they form a straight line? Those two angles together make 180 degrees. They form a straight line. Okay, let's look at 3. How do you know that the measures of angle CDE and angle EDF add to 180 degrees? Well, we know they're supplementary. We know they make a straight line. We know that straight lines are 180 degrees, so we know all of those things. Number 4 says look at solve it. Give the reasons for the steps used to solve the equations. Write the reasons next to each step. We already did that, didn't we? We had remove parentheses. Next one, combine like terms. Add 6 to both sides. Finally, divide both sides by 3. Okay, now number 5. Since you know that x equals 62, what is the measure of angle CDE and angle EDF? Show your work. Okay, let's do it. Let's go angle CDE first. So, angle CDE. Okay, go back to my picture. Angle CDE is 2x plus 1. 2x plus 1 degrees, right? These are degrees. X is 62, so let's substitute. 2 times 62 plus 1 degrees. Okay, 2 times 62. Get a calculator if you need it. 16 60 is 120. 2 times 2 is 4. 124? 124 plus 1 degrees. What's 124 plus 1? So I have angle CDE is equal to 125 degrees. Not bad. We can do that. Okay, now let's do the other one. Let's do angle EDF. Angle EDF. Okay, so I'm going to look on my paper, on my book. EDF. That's the one in red. X minus 7 degrees. X minus 7 degrees. X is 62. I already know that. Substitute. 62 minus 7 degrees. 62 minus 7, 55. 55 degrees. So now, these are supplementary, so if I add those together, they sure better equal 180. So 125 plus 55, 180 degrees, so I'm in good shape. Okay, let's keep going. Number 6, what is the measure of angle ADC? So let's take our finger, ADC. It's the little question mark in our picture. Now, I can solve this 2 ways. I know that that angle plus 125, it's supplementary. I know that. But the easier way to do it, it is opposite. It is the vertical angle to angle EDF. We just did this. So angle ADC is the same as this. So number 6, angle ADC is 55 degrees. I already calculated that, and it's just opposite. Okay, explain your reasoning. I'm going to say that ADC and EDF are opposite. Angle ADC and angle EDF are opposite. You could say they're vertical angles, same measure. That's kind of cool. Okay, number 7. What facts about angles can you use to find unknown angle measures? Well, what were the definitions we just talked about? We can use the facts if they're complementary. Do they equal 90 degrees? We can use facts. Are they supplementary? Do they equal 180 degrees? We can also use vertical or opposite. That's a handy one. So if I know the angle across from it, I know that angle too. They're opposite of each other. They have the same measure. Okay, number 8, let's try it. That's quite a picture. Okay, I'll do my best. Go ahead and solve it. I'm going to draw number 8. Okay. Oh no, I put C in the wrong spot. Well, I guess that's okay. That is C. Okay. All right, so what do I know? I know, let's get some colors. I know that this is 3x plus 5 degrees. So if that's 3x plus 5 degrees, so is that. Okay, what's the other one I know? I'm going to switch colors. Go purple. I know this one in here. This one is x plus 11 degrees. Now, notice, do you see this? Straight line. Those two are supplementary. They equal 180. So let's write this out. Okay. They want to know what's the measure of angle DCB. DCB. So I want to know this angle. I'm going to write it blue because that's blue. I need to know this one. Angle DCB. And then I also want to find the angle ECD. ECD. Oh, in here. Purple, right? I want to know this one. That's angle E, C, D. Sorry, my C is very messy. My apologies. Okay. All right, let's solve for x. So let's go over here and do this. I've got 3x plus 5 plus x plus 11. This angle plus this angle, they're supplementary. They equal 180 degrees. All right. My favorite part, let's combine like terms. Let's circle the x's. Remember to take the sign in front of it. And let's box the numbers. Okay, here we go. Let's combine like terms. What is 3x plus x? 3x plus x. 4 x's. Okay, what's positive 5 plus 11? 16. Still equals 180, right? Make sure I'm doing, I guess we'll find out if I'm doing math right. Okay, now I want to solve for x. So let's remove our 16. Let's subtract 16 from both sides. 180 minus 16, what would that be? Is that 164, is that it? 180 minus 16. Oh, here, I'll just do this. 164. Okay, now I'm going to divide by 4, right? I want x by itself. So 164 divided by 4. Well, 16 divided by 4 is 4. 4 divided by 4 is 1. So I'm hoping that x is equal to 41. Now, almost done. Now I know what x is. I'm going to go back and put it in here, and I'm going to put it in here. Okay? This one's probably going to be the easiest. Let's do that one. What's x plus 11? What's 41 plus 11? 41 plus 11, 52. So that should be 52 degrees. Oops. 52 degrees. So if this is 52, the angle opposite, I wrote it in purple, angle ECD is also 52. Okay, so far so good. I know this has a lot of steps, but we know how to do all of these steps. We just have to take our time. The good news is you can pause, you can rewind me, and do it again. Let's do this one. This one's a little harder. 3 times x plus 5. Okay, so I have to do 3 times 41. 3 times 41. Oops, I erased it, I can't remember. Plus 5. All right, 3 times 41. So what is that? 123? Yeah. 123 plus 5. 123 plus 5, 128. So this should be 128 degrees. If this is 128, the opposite angle is also 128, right here. Now, I can verify to see if I'm correct, right? I can add these together and they better equal 180. So 128 plus 52 is in fact 180. And then these are opposite. So angle ECD is 52 because that's 52. And then angle, how did I write it? DCB is 128 because the opposite angle is 128. And if I add all 4 of these together, what should it equal? 360. You got it. Okay. Excellent. All right, not too bad. Tough, but not too bad. All right, so what I want you to do now, later, is to work on the homework. Your homework is going to be practice and problem solving 195 and 196. And I'll do the same thing that I did with your homework from last week. I'm just going to post the pages from the teacher's edition, and you can check your homework that way, okay? All right, we did it. Okay, so that was our first one. I'll probably do another one tomorrow, a little shorter, no notes tomorrow. And then I'm also going to, when we go over the guided and independent practice, I think I'm going to videotape just me working on paper. So not this, but picture, the video of me writing. So we'll see how it goes. Fingers crossed that it works well. Okay, love you guys. Talk to you soon.